Yes. Yes, yes, yes. I fixed. I I muted the music instead of unmuting the mic. I'm good at this. Oh my god. Uh, I am dumb. That has been my audio problems all night. I was going to stream like 3.5 hours earlier. And I just need, oh god. Oh, hiya woo! Wow, 9-month streak. Thank you very much. Oh, hi. So yeah, so the plan is to do some work on Squishy. I am unsure. Oh, thank you for the follow. I am nope, that was right. Tickle cries. So yeah, the goal is to probably work on some Squishy stuff. Oh, okay. There we go. Oh, hi Doric! Hi! Wow, there's all kinds of people here today. Yeah, but the idea was to work on maybe some Squishy hardware. Tickle your cat girls today. No tickle. There's still a bit of stuff that needs to be done here, like wiring up the ULPI interface. I think there's some more PSU stuff that needs to be sorted. I was a dumbass and didn't leave a to-do note. Oh, it's something to watch. Well, thank you. You're welcome to hang out. Flash. So basically all of this needs to be laid up. I was thinking about cutting the number of LEDs in half and spacing them out a little more so we have room for light pipes. I don't think we need 10 LEDs. Yeah. Excuse me. Also, I'm sorry, I am very sleepy and wiggly as I have run out of caffeine. We could do that. With Squishy version 2, it has a much larger FPGA, so we could probably try and fit an S360 emulator in there. Another thing I probably need to do is space these test points out so that they are, you're able to get pogo pins there. Boopity boop. We also need to think, can it play SMB? Maybe! Oh my god, I'm sleepy. I'm sorry. So the power supply stuff, there's some various test points. Oh right, we were working on Hyper RAM, I think, last time. Oh, hi Amy! The Hyper RAM, which also we need to figure out where it's going. I think I might have a to-do list. Hardware plans. Squishy Rev 2. Yeah, that's not super useful right now. Let me pull up the schematic. Right, there is pull downs for the JTAG. That's the that's the big chunky scuzzy connector, which needs wiggling. There's the DUT and programming header, which so the DUT and programming header is this abomination of a Samtech part. Gotta give it. Oh, cool. Keycat crashed. That was fun. Why did Keycat crash? Oop. Gotta love Keycat crashing. Let's try that again. Okay, yeah, no. That's super fun. Excuse me. Oh, it very well might be an Open Cascade update. I'll just not deal with it then. Squishy. Alright. We'll just not get to do 3D. But this is a very chunky connector. I actually have photos of it on Twitter. I will have to find them for you. 1 second. Uno momento, por favor. Anyway, how's everybody doing tonight? Hanging in there, I hope. I'll find the pictures I'm looking for eventually. Give me a second. Well, it's good to hear you're doing good, Dork. Oh, thank you for pats. Yeah, I've heard of The Legend of Mana. I've never played it or seen it been played, so I have no context. Come on. I have the connectors. I post too many photos to Twitter. Yeah. Vibin. Oh, hi! Hi, Real Trends. Vibin's good. Vibing is important. Oh, come on. I really need to, like, categorize these things. Oh, Legend of Mana? Okay, so these are the connectors. They are self-mating, shielded. They're good. So these are the debug and programming connectors I'm using for Squishy Revision 2. They are very good connectors. They're very expensive connectors. They're like $5. It's not that many pins. It's only 120 pins. It's not that many. No, it's not even 120. It's 40 pins. Yeah, 20 and 20. That's only 40 pins. Oh, and then I have these for people who are wondering what the Squishy Rev 1 stuff is looking like. So this is Squishy in its prototype form, and then there is Squishy Rev 1. So this is the first revision of Squishy in its existence at the moment, including all of the bodges, including having the flash up on a little interposer board because the Ice 40 won't do other stuff. Boot from the other flash. This still needs to have some... It needs to have the FPGA have its I/O properly configured. So the appropriate enable and disable signals are pulled instead of left floating. I wonder if you can do that. I wonder if there's a way in the FPGA tools to get the set the default state of the I/O. Right? It's great. It's actually not that bad. Okay. So that's that. But yeah, debug and programming, which is then broken out to this grid up here. That needs to be sorted out. Flash needs to be eventually routed to the FPGA. We're using an ECP 5GUM because it has the transceivers. And what I also want to do is I want to route a pair of transceivers over and up through this connector. So we could probably make a fiber channel adapter for Squishy. Because what is fiber channel but wiggly scuzzy? Supervisor needs hooking up. Yeah. I'm tempted to run a trace. There's no room to. I want to get rid of that air wire because electrically they're connected, but KiCad doesn't think they're connected. Right? But yeah, let me kind of explain how this is going. How this is planning to work. So you have your USB-C here, right? Because we're moving to USB-C and USB 3.2 Gen 1 on Squishy Revision 2. So you plug it in, and then it talks to the PD controller over here, which lets us configure, like, you know, how much amperage over the 5-volt line and stuff we want. Which then also tells us the plug direction, which we feed into this high-speed mux switch. So that takes our super speed lines through these ESD diodes and shoots them off in this direction, which they can then meet up to the transceivers in the FPGA. Then the USB 2 lines also go to the PD controller, and then they also fork off to a ULP5 for full speed for the NUMI stuff, which we then need to route into this side of the FPGA, and we gotta length match all of that. Still don't know where we're putting the hyper ramp. Yeah, I'm unsure where the hyper ramp should go. But in the end, I have a flowchart. I have a flowchart. And I did this flowchart in KiCad. So this is how the USB boot up would go, right? This is roughly how the USB front-end gateware stuff will work for Squishy Rev 2. If that makes any sense. Yeah, I'm sleepy. Sorry, I'm also partially just re-familiarizing myself with everything in here. Meow. Yeah. I'm re-familiarizing myself with everything in here because I haven't touched this in like 7-8 months. Boop-a-boop. I don't remember if we needed anything done with the power supply. I should have left notes. I have a dangling 1v1. I have a dangling 1v1 node. Yeah, silk screening at the FPGA. Thanks. No, I don't think the 1v1 supply needed building. Yeah, the supply's there. I think we need to adjust the power sequencing. I think that was one of the things we need to do. I think this is for decoupling the VCC analog rails. Let me just add that. Boop. Yeah, state machines are really good. Oop. Yeah. Also, the hyper. I don't know. This is cute layout for that stuff. Power LED, fiducials, mounting holes. Yeah, I think we need more decoupling. Yeah, okay, I have the needed rails over here. I left some notes for myself. We have an LTO5 library. It goes beep boop, bleep bloop. What graphic could you possibly mean? I can't see it. I don't know which graphic you're talking about. What graphic? What? I would like to. Hi. Oh, I think I need to increment this this counter again. This is an important counter to have on your schematics for hardware design. Design decisions made out of spite. Okay, it looks like that's all hooked up. It just needs to be routed. Yes, I recommend it. The HyperM cache can talk directly to the FPGA. I just need to... Figuring out which bank goes where is the hard part. I think I've allocated these banks to be purely SCSI stuff. I think I've already done bank pre-allocation for the FPGA. So I'm pretty sure this is for the ULPI PHY stuff. I don't know. Yeah, it's spike counter is important to have. I need to where's like R20? Yeah, okay, so this is definitely the ULPI side of things. What I might be able to do is just... I'm trying to figure out how to organize this. Electricity, present. That is left for viewer discretion, and I think it's fairly obvious in some cases. I mean, Fiber Channel is just technically SCSI, except it's a little more wiggly. I guess we can... These all have to be length matched. The length matching tools... I want a bus router. I'm not entirely sure what you mean. Yeah, I am not too terribly sure what you mean by that. No, they might not need length matching when they're short, but this is actually a fairly far distance. This is a whole... where's the ruler? Where's the ruler tool? What? Ruler? Is the ruler broken? Oh. Ruler's broken. Keycat's broken. Oh, what? Because my grid is absolutely ginormous. This is a whole 1 centimeter. That's... Okay, it's more like, you know, directly it's 1.3 centimeters. The whole one... Right, but the traces are going to be longer than that. Also, this is fun, aren't we? We're saying that 1 centimeter is far. I guess... What's the lambda for 60 megahertz? Speed of light in copper? No, I trust you. I'm just... One centimeter is not a lot. It's just... It's far enough where I have to... And our signals are fast enough where I might have to consider length matching. Does Kika have... Yeah. I could also, like, impedance match... Probably, like, impedance match these and fan them out. Or just not care. I am slightly concerned about the phi reset being very close to this clock, though. 1/60 megahertz. Did you try to post a URL? Did AutoMod get you? They're not overlapping. There's still plenty of space. I'm pretty sure DRC is fine. We should run DRC. I haven't run DRC. How badly is this gonna explode? What are you complaining about? Yeah, so DRC says they're fine. No, they're on the same side of the board. If you're talking about this is a decoupling capacitor and it's blue. It is on the other side of the board. 53 nanometers? Is that... I'm still worried about timing. Yeah, so this is the clock. It's a group of components, but the clock is here. And then there's a decoupling capacitor on the other side of the board. This is so this is a this is a 6-layer board. Here's the board stack up, which I painstakingly drew out. But we've got top copper, bottom copper, and then we've got the prepregs and the cores. And then so we've assigned power to the second, third, and fifth layers, and then ground and signal to the first, fourth, and sixth layers. Oh, now there's a bunch of red arrows over all my shit. I can just turn the warnings off. That'll Who cares? Prepreg is it's well, yeah, that's the main. It's the silk screen stuff. I'm not too worried about that. Prepreg is epoxy impregnated fiberglass sheets, and the prepreg is thinner and more flexible than the core material. If you have any questions, feel free to ask. Sata, nah, it's the Scuzzy. Okay. Right, but the slack. I get. Alright, tell you what. I'll route it without length matching. Oh, you'd be surprised. You can get trace lengths very long in circuit boards. When you have to wiggle around things and change layers. But okay, what I will do is I will route it over without length matching. I'll probably want to spread them out and so I can decouple them. I thought it was DDR. Yeah, so length matching is ensuring that all the traces are the same length. Like, see how this one is longer than this one? to make these the same length, I would have to wiggle this one. Yeah, thank you. All right. I should start writing a to-do list. Requirements, wish list items. Do-to list. Okay. So what we need is, yeah, wiggly traces. So what we need to do is remove half of the cis LEDs. The FPGA I am using for this design, oops. There it is. There's the FPGA. Oh, hi, good evening. Yeah, using an LEF 5UM5G 45F 8BG381C. Oh, hi, Expired Popsicle. Hi, kitty. How are you doing? Go check out Kiri. She's new. It's a lattice part. I have some. No, ECP5. Yeah, go check out Kiri. She's cool, and she's also the newest member of Not Put Her Live. Go check her out. She's a cool snake. Yeah, so revision 1 of Squishy used an ICE 40 HX8K. This one's using an ECP5. Well, now she is. Now she is a member. Yeah. Okay, I was writing down to-dos. Remove half of the cis LEDs. Route the Ulpify. Blah, blah, blah. Route the SPI flash. And then we need to route the supervisor connection to the FPGA. I can spell supervisor. I promise I can spell supervisor. Come on. Dip. Boop. Oh, I also need to route the super speed lines. Yeah, pronouncing initialisms is always fun. I like that. Okay, well, what else do we need to do? I think that's a good start. The power stuff. I'm not convinced these LDOs will have enough oomph, but maybe they will. The power side of things needs to be unfiggledy-fuggled. No, bad, funk. I don't even have an auto router set up. I should probably change my grid to not be 0.05 millimeters. Now it's not on grid. Cool. I guess I am using this grid. Topper probably could. But then again, Topper is cursed in the best of ways. Okay. Okay. No. Your obsession with Tickle concerns me. Okay. All right. Boopity boop boop. Okay, I need to go. Ah. Your obsession with Tickle concerns me? Tickle, the programming language. TCL, pronounced Tickle. What is that error? Oh. I don't remember where this was from, but there it is. U20 is where? Alright, well, what I will do is I will copy this real quick. That is terrifying. Doop-a-doop-doo. God damn it. Okay. So if I just... what was the hotkey to flip it? Y? X. Oh no! Something went horribly wrong! Okay. Okay, that was bizarre. Come on. Yeah, okay, that's doing what it's supposed to. Why did it explode like that? Oh my god. Oh, right. I do need to make sure that there's a clock-capable input on bank 3. Because I need to route the ULPFI clock to the global routing, the global clock network in the FPGA. So that means we need to look up the data sheet. I actually might already have this. documents. Ba, 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 ba. I'll just download another copy. 55. Ah. And we want the pinout. This will tell us which pins are clock capable. I'm sorry that is so bright. And then we want the BG381. CBGA 381. That's the one we want. So we can delete these columns. And then we want bank 3. Okay, so P clock 3. Boop, boop, boop. L18 looks to be clock capable. L16. Oh, hi, Kiros! L20 looks to be clock capable. Do we not have L20? Oh yeah, there's L20. Where's L20 on the board? L20 is way up there. Where's the clock? There's... Where's the clock out? There. Okay, that's not gonna work. L20 won't work, but... if we find an inner one... M20 won't work. Oh, that's annoying. It looks like all of the clock-capable pins are up here. Which I guess makes sense, but that's slightly aggravating. Yeah, those are, well, P17. That's in there, though. Or U16, that one's also clock capable. I like the short pins. I like short pins. Alright, well... we're going to need this to wrap around this whole thing anyway. Oh, god damn it. Come on. Alright. Yeah, I honestly, I don't know much about TCL, and I am thankful. I am thankful I don't know much about TCL. Alright, I'm going to leave the clock unrouted as of yet. But I want to try to keep the Phi stuff down Down here. This is the hard part. BGA breakout and pin planning is the hard part. I don't mind it. I'm just trying to think about how to best get this stuff there. Because BGA pins. These traces are not the same width. 0.1542. Yeah, these traces are not the same width. There we go. That's better. It's like, why is that trace thicker? Thicker! Okay, I added more accursed lines. Honestly, I think I just need to pick a clock-capable output pin and then... No rounded traces. I like my 45s, they're comfy. – 45-degree traces are comfy. M... Yeah, it's going to... The clock trace... 45-degree rounded? Maybe. We can always round the traces afterwards. We can always make them round later. Okay, so... T16 and T17 and U16 are the only other clock capable... These are the only other clock capable pins. And they're like... They're all the way... Their ass is all the way in here. Although T17... I could make that work. It wouldn't be fun, but I could make it work. So this is the only reason this is the main problem is because the phi I'm using is the type of phi that takes in a 13 megahertz clock signal and spits out 60 megahertz. So it feeds the target device 60 megahertz instead of it feeding it getting fed the 60 megahertz for the device. But yeah. Oh, clock is all the way up there. Clock is in a very annoying spot. I think I can make this work with some effort. I think I can make this work. If I go T17 is now the new clock, right? Move these off. Okay. So T17, there's the clock. I should have... I've been kind of hesitant to hook anything up to the FPGA as of yet, because I'm not sure this design is finalized. And if I move the FPGA, I have to redo a bunch of routing. And that takes effort. Alright, I need to get some water. I will be right back. Don't burn the place down while I'm gone. Hey now, I told you not to do that. I'm back. Excuse me. Oh, hi. Thank you for following Tech Talk. Pardon the evidence. Is there anything that I should route before the FPGA? Yeah, there's a whole bunch of stuff. Honestly, I'm not even sold on this layout at the moment. The board dimensions are covered up. 85 millimeter. So they're 85. It's 85 millimeters by 90 millimeters, basically. Maybe? Alright, I'm just gonna start roughly escaping these. What those? What those? I haven't. I don't follow the ATX stuff too often. Or the Raspberry Pi stuff, rather. So let's just make some wiggles. Where's the halfway point for the FPGA? Okay. The FPGA is not centered anymore. Yes, I have been mentioning making a replacement board for the ThinkPad. Boop, 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 boop. Okay, that is literally about halfway up the FPGA. Keycad. You can do it. You can fit. Uh, boo boo boo. That's not correct. No, that is. Yeah. That's going to be problematic because that needs ground. It's going to have to come up here. You're going to have to go up this way. BGA breakout is kind of annoying. They're not that evil. I mean, I would like to see a better way of doing things. There really isn't at the moment. Hello? It does. The board says Numis. Just got 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 7, 8, 9. Seven. This is hard. BGA breakout's hard, so I want to keep the bus as planar as possible. Gary, help, I don't know what I'm doing. Saying help, I don't know what I'm doing. I'm stuck. No, but the clock needs to go into a global clock network capable pin, which is either T17, T16, L20, L19, M20, or M19. And I don't want to cross the clock over a large chunk of the bus. Because I don't want hold violations. Well, it's not like I can highlight specific pins explicitly. There's no way to like I can click on a pin, but then if I ever click on something else, it goes away. I also turned off high contrast mode. I could, but I don't want to. What red circle? Tiny red circle. No. Oh, L18 is also a clock-capable pin. And L16. It's not centered, but it doesn't matter. I know that's gonna bother people. Well, I'm not cool. L17. L16. No. Right. L18, L16. L18. L16. M19. This one. M20. L19. L20. Those are all the clock-capable pins. No? Hello? Let's see, 1, 2, 3, 4. I have 4 that I need to route. I might be able to do this, but I'd be using up all of the clock-capable pins right here. Well, because I'm making the blub blub movements in real life. I do that while I'm thinking. I go blub 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 while I'm thinking. I'm not using them up. Well, use other pins for non-clocks. Well, yes, that's the plan. I don't want to tie up all the clock-capable pins. Also, the main oscillator is over here, anyway. So this clock's going in here somewhere. No, it would just use up all the clock-capable pins up in this section if I were to route it how I was thinking. Okay, it wouldn't use up all of them. It wouldn't use that one. But it would use these 6. Or 5. God, I'm an idiot. I'm confused too. I am confusion. I forgot. No brain. Brain is pudding. I have a headache. Excuse me. Oh, no, don't want to... Actually, that should be locked. I should not be able to... I should not be able to select the FPGA. Okay. Let's try this again. I'm sleepy. Excuse me. Oh my god. Crunch. Oh, that's not right. That's in a different bank. I can only use bank 3 at the moment. Also, these are going to the SD card. All of these pins are in bank 3. Oh. Okay. So these are the pins I have available to me. Yeah, I should add bank, the symbol bank stuff, but bank 3 is right here. This is bank 3. And then this is the right side transceiver. Top is here. Pin 1 is over here. Well, okay, technically it doesn't have a pin 1, but, you know. But basically I can't go above... I'll draw a line. This will be good. Come on. Can't go above that line. Can you route some of that bank, the empty space? Here? I really can't. This is all transceiver stuff down here, which is the high-speed sensitive. I want to avoid that. I really should do power for the FPGA first. Actually, I'm tired enough where it might be beneficial for me to try to sleep. Or stop for now. It has been an hour, which is good, but I need to work back up my streaming. Oh, someone died. I need to work back up my streaming stamina, so I think we're gonna call it here. Wow. There was an ambulance that drove by. Who should we raid? We can raid KT. Let's raid KT. They're doing Deep Rock Galactic. But yeah, thanks. Have a good one, yourself. All? Yes, all. I'm sorry, my brain is just entirely shut down right now. Yeah, thanks. Have a good night. I'll try to do a longer stream this weekend. Yeah, hopefully I'll get to do a longer stream this weekend and everything will be happy and kosher and yeah. So, I'll see you all around. Thanks for stopping by.